Okay, guys, so this is part 10 of our exponents and sets. Okay, so we have pushed so far, we are almost done with this topic of exponents and sets. So we are on part 10, exponents and sets, and we are still under the same subtopic, being exponential equations. Exponential equations. Okay. So let us just continue. I think on part 9 we did example 12, right? And example 13 we only did example 13. So today, guys, I would just like us to do example 14 under this same topic. Example 14. So here actually, the question that we have here, it's more like we have to prove. Okay, so the first question, A1, we have to show that 5 times 2 exponent x plus 3 times 2 exponent x plus 2 it is equals to 17 times 2 exponent x. Okay, so this is exactly what we are required to prove. Okay, guys, so we are supposed to show that this part, it is the same as that one. It is the same as 17,2. Okay, so quickly let us go with the left hand side of this thing. So the left hand side, and let us rewrite it. It is 5 times 2 exponent x plus 3 times 2 exponent x plus 2. Okay, so let us just continue like that. Left hand side is like this. So now what are we gonna do with this, guys? Just notice that we can make this one make it to be 2 factors of 2 exponent x plus 2. So that's exactly what we are going to change now. Then let us change that one. We are going to write it as 2 exponent x and 2 exponent 2. Right, so it is the reverse of multiplying the powers of the same base at the exponents. Okay, so if you have exponents added, then you can separate them to two same bases. Okay, so why were we doing this? Because we were just looking for this 2 exponent x and that one, so that it can be common on these two both terms. Okay, so our left hand side is going to be, we took out 2 exponent x as a common factor, and you remain with 5 plus 3 times 2 exponent 2. Okay, then from there, our left hand side is going to be 2 exponent x into 5 plus 3 times 4. Okay, then our left hand side, it is equals to 2 exponent x, and there it's going to be 5 plus 12, because of 3 times 4, it is the same as 12. Okay, and left hand side now, it is equals to 2 exponent x. 5 plus 12, it is the same as 17. Okay, so remember that multiplication, it is commutative. So what do I mean by that? It means that the order doesn't matter. So we are going to write it starting with 17. Okay, so our left hand side is equals to 17 times 2 exponent x, because of that's how they want it, from what they wanted us to prove. Okay, so then you can say that left hand side, it is equals to right hand side, simply like that. Okay, quickly let us take another one again. Let us solve this one. So this one we are asked to solve. Okay, so actually it is a follow-up question. So it says that number 2, hence solve 5,2 exponent x plus 3 times 2 exponent x plus 2, it is equals to 68. Okay, so it is equals to 68. Okay, so this is a hence question, guys. So once they use this way, the hence, they simply mean that the thing that you were busy with before, it will be useful. Okay, so it will help you to work out this one. Okay, so how so? Then we already know that this thing, this part here, it is the same as 17 times 2 exponent x. Okay, so now this part, let us write it as 17. Let us write it as 17 times 2 exponent x. This part, okay, we know that it is 17 times 2x because of we times 2 exponent x, because of we have already proven it. Then it's equals to 68. Why are we using that? Because of this way, the hence. Normally, for hence questions, you will be needed to use the previous information or whatever that you got when you solved the question before the one that you will be solving. Okay, so now this is 17, 2 exponent x, and then now what can we do, guys? Quickly let us remove this 17. Okay, so remember now we are solving x here, so we divide by 17 both sides. Remember, solving x, it has to do with isolating x, so we want to remain with x only this side. Okay, so once we 17 will cancel 17, and then 68 divided by 17. I know that it's 34. 17 times 2, it is 34. Okay, so now 34, it is made of 68. Then it simply means that 17 goes into 68 4 times. Okay, so you could even simply use your calculator and get this part. Okay, so 2 exponent x, it is equals to 4, just like that. Okay, and from that we know that 2 exponent x, we are going to change our 4 to be a to have a base which is a prime number. Okay, so 2 squared, like that, and then you can simply drop your 2's because of you have the same basis, then x will be 2, simply like that. Okay, then let us go for b. It was strictly solve x. B, it is about solving x. Let me see which color can I use. Okay, let me use this white. Okay, solve for x. Okay, so number 1, 9 exponent x plus 3 exponent 2x plus 1, it is equals to 4 root 3. Okay, so quickly let us go for this one. It's a bit complicated, but then we know that we are equipped with so much tools. Okay, so quickly let us just change everything to be a prime number. Can we do that, guys? Yes, we can. Okay, so 9, it's gonna be 3 exponent 2, not 3. Don't forget that x plus this one, it is already in a prime number, the base is already a prime number, but then because of we have 2x here, we can already see that we might need to make 2x as well here, so that we can have a common factor. Okay, so 4, you can change it to be 2 squared, and then 3, you can write it like that. Okay, I hope you guys get to understand this. So 3 exponent 2x plus 3 exponent 2x times 3 exponent 1, it is equals to 2 exponent 2 times 3 exponent 1 over 2. Okay, so now you can simply see that 3 exponent 2x, it is common. You have it here and you have it there. So quickly take it out of the brackets. 1 plus 3, like that. Then it is equals to 2 exponent 2 there. Just leave it like that. And then 3 exponent 1 over 2. Okay. And then now, you can simply say that this is 3 exponent 2x times 4. Right? It's equals to 2 exponent 2 times 3 exponent 1 over 2. Okay, so now you can see that you want to remain with this x here. Okay, remember we are solving x here. So I would advise you that firstly, remove this 4. Okay, so and then now you will notice that this thing is also same as 4. I hope you guys noticed that. Okay, so we could have even changed this one and then wrote it as 2 exponent 2. Okay, so this will go away with that, this will go away with that. Okay, and then we will remain with 3 exponent 2x, it is equals to 3 exponent 1 over 2. Our bases are the same. Since our bases are the same, we are allowed to drop our bases and remain with our exponent, which is 2x, it's equals to 1 over 2. Okay, then we are looking for x. Divide throughout by 2. Divide throughout by 2. X, it is going to be half divided by 2. When you divide half into 2, you get quarters, right? Like that. Okay, you can just press it on your calculator, that one, and then you will get the answer. Cool. Then now let us quickly yes, we are done with that one. X is equals to 1 over 4. And then yeah, before we do that, let me just share our exercise, guys. Let me put it in the middle this time, so that those who do not watch these videos, who just want to browse them, so that they may struggle to get this homework. Okay, so let me give you homework quickly. So okay, guys, so this is our homework. Please screenshot it. So this is the first part of our homework, and then this is the second part of our homework. Okay, guys, I hope this time it will be visible. I know that some of you had challenges later on to get this homework because of it was not visible. Okay, so quickly let us continue with our last problem. Okay, problem number 2. So why am I doubting, guys? Okay, please screenshot this, guys. Exercise 8. This is our homework. I hope you have managed to screenshot the first part, and this is the second part. Hope you also managed to screenshot it and practice with it. Okay, cool. So now let me just continue with the last problem for this video. So we have the problem here. Okay, let me just check if I do have pink. Okay, so here is our problem. 3 exponent 2x. I'm sorry about that, guys. that thing, guys. Let me just share my full screen. So 3 exponent 2x plus 6 times 3 exponent x minus 27, it's equals to 0. Wow. I wonder. Okay. So how are we going to approach this one, guys? You have 2 ways of approaching this. Okay. So the first approach, you can simply use the let method. Okay. And then the second approach, you can just tackle it straight. Okay, so the first approach, you can use the let method. So you notice that you have okay, so you can separate this 3 exponent 2x to be 3 x times 2 like that, plus 6 times 3 exponent x minus 27 is equals to 0. Okay, so now you will simply notice that this thing is a trinomial expression, guys. So that's why I want you guys to master your algebra. Okay, so if you have mastered your algebra here, you should understand better. Okay, so it is a a quadratic trinomial expression. Okay, so how so? Because of this, if this was to be, okay, let us let 3x, because of it is the one that appears most than others. Okay, so let 3x to be let's say a. Okay, so what do I mean by this? I mean that wherever we see 3x, we are just going to write a. Okay, so you will understand why am I saying that this thing is a quadratic trinomial. Okay, so let's do that. So we see a 3x here, we write it as a. Don't forget that 2 there, plus 6. We see 3x here, we write it as a, minus 27, it's equals to 0. Can you guys see that? So you can see that this is a quadratic trinomial. And then from there, you can quickly use your quadratic formula. And then from your quadratic formula, but then I'm not going to use the quadratic formula, guys. It will just waste my time, but then I encourage you to use it. So I'm going to open 2 brackets here, okay? So if I open 2 brackets here, the factors of a squared are a and a. And then the factors of minus 27, that will give me 6. When I add them, it's minus 3 and plus 9. So these 2 factors, when you multiply them, they give you minus 27. And then if you subtract them, they give you what? They give you, if you add or subtract them, they give you positive 6. Okay. Then from here, you can simply say that a minus 3 is equals to 0, or a plus 9 is equals to 0. Then a is equals to 3, or a is equals to minus 9. But then you are not done. Remember that this a, you used let. So remember that this a is the same as what? As 3 exponent x. Okay, it equals to 3, or 3 exponent x, it equals to minus 9. Are we together, guys? So now let us quickly say that here you are safe to drop the basis, because of you have the same what? You have the same basis. So x is equals to 1, or now this one, guys, let us discuss this one quickly. So now what's happening here is that you see this minus 9, we will not have solution. Okay, the reason being that 3 exponent x is greater than 0 for all the values. So always when you have something, when you have anything to exponent anything, okay, let me say that any positive value to exponent any positive value, it has always to be positive. Okay, so you can try it. Okay, so it will always be positive. It can never be negative. So for this one, you simply say that no solution for that. Okay, so your answer will be no solution. Why? Because of 3 exponent x will always be positive. Okay, will always be positive like that. Or you can write it like that. How do I know that, guys? You can replace, remember that x can be anything, right? So you can replace x with anything. Whatever you replace x with, it will be positive. But then according to this equation here, they say that it must give you -9. So this is impossible. Here, anything that you replace x with, it's going to be positive. Okay. I hope this makes sense, guys. But then if it doesn't, I think we will have a topic based on this part only. Okay, so there's a certain topic that we can do. But then let me try to emphasize again. Remember, this x, you can replace it with anything. Here, you can replace this x with 1, then it will give you 3. But then here, what are you going to replace this x with so that you get -9? It is impossible. At least if this -9 was positive. Okay, if it was a positive number. So then you can conclude that every time, whenever you are having a positive power, okay, it can never be a negative number. Okay, so a positive power can never be a negative number. Thank you, guys. I appreciate. I will see you when we do a part. Which part? I will see you guys when we do part 11, okay, of this exponent.